Okay, welcome back to Every Problem. We have Stewart, 8th edition calculus. This is chapter 1, section 1, problem 2. It's the same style as problem 1, but a little bit trickier. So it says if f of x equals x squared minus x all over x minus 1, and g of x equals x, is it true then that f equals g? So let's go ahead and get started with the tricky part of it. So if we take f of x equals x squared minus x all over x minus 1, algebraically, we could very quickly tell ourselves, oh, well, why don't we just factor out an x and have x minus 1, right? X times x minus 1 all over x minus 1. And why can't we just cancel these out? And that leaves us with x and say, aha, there we go. F of x equals x and g of x also equals x. So therefore, we're done. And f is equivalent to g. So the big question is, why are we not allowed to just say that? Well, one of the most important things to keep in mind is that a function is a rule. And what we're not supposed to do is we're not supposed to change the rules as we feel. So f of x, it looks like it behaves like g of x. However, there's one single spot where it does not behave like g of x. And what I mean by that is, let's take f of x. Let's find something a little bit more concrete. So f of x equals x squared minus x all over x minus 1. Well, what would happen if we found something to make the denominator 0? Well, let's say we plugged in x equals 1. So we would have 1 squared minus 1 all over 1 minus 1. And that would end up getting us 0 over 0. And in math, 0 over 0 is not equivalent to 0. It's something different, something unknown. So basically what happens is there is what's called a removable point of discontinuity, where the function f of x, it behaves like f of x equals x, except for when we get to x equals negative 1. There's going to be a hole in the graph. And then it continues on. So, all of that said, does f of x equal g of x? The answer, though, is no, because f does not equal g for all inputs. So f does behave like g. However, as we've said again, at f equals negative 1, at f of x equals negative 1, there's some thing in the graph, some sort of hole in the graph that we can't really account for. And so because of that, the graphs are different. And that's pretty much it. So thank you.